Asian magazine say.
Barkha is asking me why only mean statistics is used, not any other statistics like median and mode. Why not this? Why only mean? Barkha, if I go into technical of it, mean is one of the best estimator. And why it is best estimator? Because it is unbiased estimator. It is consistent estimator. It is efficient estimator. It is sufficient estimator. Because mean is satisfying a lot of good qualities of a good estimator. That's the reason we go for mean testing rather than median and mode, which are not good estimators. Okay, that's Barkha is precise reason for it. Okay. Regarding the books, etc., I will share the books with Anjali and she can forward the same to you. Okay. Any other question before we go ahead? Any doubt? Any clarity you want?
Hello, sir.
Jagdish is saying what to do when test value is not available. Jagdish, I don't see any reason that you don't get a test value. All tests are already developed for each and every situation. So I don't feel that you will ever feel a problem that for a particular hyper testing, you're not getting any test. That possibility is not there.
Hello, sir.
Yes.
Sir,
Yes.
I have a question like, let's say I'm testing the relationship between medicine and a disease, let's say fever.
Okay.
और इसमें जो null hypothesis है, it goes rejected. So वो 5%.
एक second. Null hypothesis क्या है?
There is no relation between medicine and fever.
No relation between
medicine and fever.
Okay, alternative.
There is a relationship between medicine and fever.
Okay, so null is rejected.
Yes, at 5%.
Right, that means there
So
is a relation between.
Type 1 error क्या define कर रहा है इसमें?
Type 1, that the decision which you have here you have not rejected, no?
We have rejected.
Right. So there are 5% chances that your decision might be wrong.
5% chances that
decision of rejection might be wrong.
Decision of rejection might be wrong or hypothesis might be wrong.
No, hypothesis not wrong. Decision is wrong. Hypothesis is hypothesis. That's your decision. Hypothesis is not a decision. Error is only when you commit a mistake. You commit a mistake when you take a decision.
But that means that it should have been accepted, but I'm rejecting it. That
Right.
is the possibility.
Right.
Okay.
Only in 5% cases that could happen.
Okay.
Okay.
That means this has got nothing to do with the relationship of medicine and fever.
No, nothing to do with that.
Okay. Okay, fine. Got it.
Okay. Anybody else? Okay. Neeraj Chawla is asking, kindly throw some light on the test of proportions. The test of proportions are same as the test of means. The tools are exactly same, no difference. So for example, if I want to find out, say, the proportion of urban users of internet banking is equal to the proportion of the rural users of the internet banking. That's my null hypothesis. Okay, independent. So I will still use t-test, independent t-test. So whatever test you have learned for the mean, the same test can be applied for the proportions. No difference. Only the interpretation will be different, nothing else. Okay, Neeraj, is that clear? But for non-parametric test, we go for median. Yes, non-parametric test can be used for median tests. That's true. Divya is asking, although it's not your topic, still allow me to ask about some good journals, websites where we can find good research papers. I don't know, Divya, which research papers you're talking about? Consumer law. Consumer law is not my area, so I won't be able to answer that question.
Sir, I've got one question again.
Shital, just hold. Shital is asking in proportion, how can we use t-test? We can use it. Shital, where's the problem in it? We can use t-test. There's no problem in it. I think, I don't know whether, Shital, what's your background? Are you from finance, economics background? Shital, can you tell me what's your background? Shital, can you tell me what's your background?
So, ma'am has mentioned statistics.
Statistics. Yes, uh, the ratios which are given here, they are all proportions. I've multiplied them with 100, otherwise all this P which you get is a proportion. So I can make use of the T statistics for proportions as well. Though SPSS will say t-test and compare means, but we can make use of the test for the proportions. Okay, so proportion is say 50, for example, that you can do it. And Shital, you have a statistics background, so I can tell you if mean is following normal probability distribution or t distribution, then mean divided by a constant number to get a proportion will also follow the t distribution. So dividing by a constant does not change, the nature of the distribution. That will still remain t distribution. Shital, is that clear? Yes, Santosh. Now you tell me what you are asking.
Sir, I got stuck up again. Like, as you said that at 5% type 1 error means that I'm rejecting, I'm making a wrong decision.
In
So
5% cases, what is that wrong decision?
that
Wrong decision is rejecting a true null hypothesis.
rejecting a true null hypothesis. So, what would be the criteria to know that actually my findings are wrong? That means by rejecting the null hypothesis, I'm coming up with the finding that medicine has an impact on fever. ये चीज गलत है, ये कैसे पता चलेगी? It
ये
may be
तो
wrong.
ये जब कोई और बताएगा गलत है तो पता लगेगा, वैसे नहीं पता लगेगा.
अच्छा वैसे नहीं था. ये टाइप बी एरर नहीं, टाइप 2 एरर नहीं होगा ये.
नहीं, टाइप 2 एरर नहीं है.
Okay. Okay, sir.
Okay.
Yes, sir.
So friends, let's start with another topic which is called analysis of variance. But before that, if you remember, we started with parametric tests. One sample, two samples, mean test, difference of mean test. But we did not discuss about what if my samples are more than 2. If you have samples more than 2 and you want to check for differences of the means among those samples, then the tool which we use is ANOVA. So analysis of variance can be applied when you have 2 and more than 2 samples, okay, right? And they should be independent samples and not the related samples. If you have that kind of a scenario, then you can make use of analysis of variance. What is it? Let's try to appreciate and understand. But before that, let's take an example and see what is the thing that comes to your mind. Center bench plastic bags below 50 microns. Use of plastic bags is banned. You might be aware of this news, and this is a news, and that news also opens up the opportunity for new businesses. And one of the business, what he started doing, paper mill started thinking of preparing, uh, producing, manufacturing paper bags. So when you produce paper bags, you have to increase the strength of the paper. And to increase that strength, what they are doing, they are mixing hardcore concentration in the pulp used for manufacturing paper. Right? The range of hardwood concentration of practical interest is between 5% to 20%. A team of engineers responsible for this study decided to investigate 4 levels of hardwood concentration: 5%, 10%, 15%, and 20%. And they decide to make up 6 test specimens at each concentration level using a pilot plant. All the 24 specimens are tested on a laboratory tensile tester in random order. And the results which have been obtained, they are as follows. So we have 6 samples, 4 combinations of the hardwood concentration. Can you tell me what should be the null hypothesis in such a case? Any one of you give me? We have 5%, 10%, 15%, 20% hardwood concentration. What should be null hypothesis? The mean tensile strength of the paper at 5% is equal to that of at 10%, equal to that at 15%, equal to that at 20%. Yes, Prasanna, you're right. All these are equal. That's my null hypothesis. What I'm doing is I'm testing equality of means across 4 samples. Okay, Abhishek is also saying that. That's good. Same. Abhishek, can you tell me what should be the alternative hypothesis in this case? Nisha is saying not equal. What not equal? All are not equal or something else? All are not equal. Meenu is saying all are not equal. Anybody else? So Surabhi is saying at least one is not equal. At least 2 means are not equal. Neeraj Chavla. Swapnil is saying at least one mean is different. Okay. Yes. Alternative will be at least one mean, any one mean is different from all other means. In other words, you can say no two means are equal. Okay, that's another way of saying it and understanding it. To say that all are not equal, that means what you are saying, mean of 1 is not equal to mean of 2, is not equal to mean of 3, is not equal to mean of 4. That is not my alternative hypothesis. Because my alternative hypothesis could be this is not equal to 2, but equal to 3, equal to 4. You can have different combinations. And therefore, we say that we have at least two are not equal, or at least one mean is not equal to anyone else. Yes, Dr. Edford, you are absolutely right. Multiple alternatives can be there. Therefore, we put in the terms, in the terminology of at least two means are not equal. Okay. I have a very fundamental question now. Why means are different? Why do we have different means? Any one of you can give me a question. The strength of the paper which you have, why the mean of this is different for different combinations. Sample properties may be different because samples are with different strengths because of different samples. That means you are saying that strength is a function of hardwood concentration. Yes, Ria, you are absolutely right. Extreme points are different or dispersion may be different. No, for those, that's not the reason. Now I put two things before you. And please think over it and think why they are looks to be different but representing the same fact. Mean of 1 is equal to mean of 2 is equal to mean of 3 is equal to mean of 4. Where 1, 2, 3, 4 represent different concentrations of the hardwood. What is the equivalence between these two statements? Can you appreciate that? Because it's going to take me to a very important research issue. Any one of you would like to say? Kapil, are you there? Anybody would like to add something to it? Anindita, can you say something about this? Clustering around a small value range. No, that's not the reason for those. Makila is saying different features but not are equal important. No. I mean, it's like this, the way you look at the problem, that way of looking at the problem makes a difference. Shital is saying one can choose wood concentration having more strength. That's true. That's the consequence of it. Okay. I tell you what difference it makes. If you look at this statement carefully, that strength is a function of, you know, different hardwood concentration. This takes you to a very important aspect of the relationship, and that is cause and effect relationship. You start looking hardwood concentration as a cause and strength as an effect. If you say strength is a function of hardwood concentration, that means hardwood concentration is a cause and effect is the strength. But if you say that the means are not equal, this way of looking at the things does not emphasize cause and effect relationship, but both are equivalent. If we go into deeper questioning why they are different, then the answer to that why will help you in understanding the cause and the differences mean in the effect. Okay, the story which I'm trying to tell you is that if you have a research which is causal research, where you are studying the cause and effect relationship, then you should look ANOVA as a tool that helps you in establishing relation that y is a function of x. Nisha, yes, I repeat it because it's a very important point which we have to understand. See, what I'm saying here, if you look at this, hardwood concentration is causing tensile strength of the paper. That's my cause. That's my effect. That means I'm studying a causal relationship, and that causal relationship many times you need in your research. Okay, that's the point which I'm trying to say. An analysis of variance help you in studying this cause and effect relationship. So friends, if you have a causal research problem where one is the cause, the other one is the effect, there you can think of using analysis of variance. But can you apply cause and effect ANOVA for all kind of cause and effect relationship model? The answer is no. It's typically applied to certain conditions that we are going to learn in this particular session. So friends, tell me, is that point clear to you? ANOVA is used for testing of equality of means of more than one sample. So you have more than one samples and you are checking their equality. Beside testing equality of means, we can look ANOVA from a different perspective, establishing a causal relationship. Like, is motivation function of plants in which workers are working? Santosh, Granger is a different concept of cause and effect relationship that's related to the time series. Here we don't have that time dimension. So we cannot talk about Granger causal relationship in the context of, cross-sectional analysis. Shital, ANOVA is having its own advantages. And in fact, Shital seems to have a statistical background. Uh, Statisticians were working very hard on analysis of variance. Parallelly, the economics people were working on developing econometric tools with regression. These were parallel development that was happening. By and large, both are targeting at the same objective, that is establishing relation between two variables having cause and effect relationship. Santosh, normally we don't use ANOVA in the time series analysis because time series has its own separate issues, problems not related to the analysis of variance. So we cannot use an ANOVA for time series. Okay. Now, when I say motivation is a function of plant, then plant is my independent variable and motivation is my dependent variable. But if you look at this dependent and independent variable nature, you will observe one thing. Plant is categorical variable and motivation is your ratio or interval scale variable. So if you have dependent, which is scale level variable, and independent, which is categorical variable, then analysis of variance can be used. Let's take another example. Do you think the risk of a company measured through beta is different for different industry? Industry is my categorical variable. Beta is my ratio scale variable. So this kind of relationship you can very well studied by making use of analysis of variance. Do you think sales is a function of the display you find in the departmental store? The display type is the categorical variable, sales is my ratio or scale variables. All these raised issues can be answered by making use of analysis. It's a tool that helps us in answering y is a function of x, where y is my dependent variable measured at a scale level, x is my independent variable, which is my categorical variable. Okay. Now let's understand what is analysis of variance and how do we do it. Analysis of variance, it is applied when one has more than one sample under a study coming from different populations or same population with different treatments. It's a hypothesis testing procedure used to determine whether mean differences exist for two or more samples or treatments. The term analysis of variance appears to be misnomer, since the objective is to analyze differences among means rather than variances. Though we call it analysis of variance, but we do the testing of means of the sample. In that sense, we say it is a misnomer. Okay. Uh, Neither misnomer means it is not properly signifying what exactly it is, because it talks about analysis of variance. So many people believe that it may be a test related to equality of variances. Since you say ANOVA analysis of variance, but we don't test for variance, we test for variance means. It's not testing of equality of variance, it's a testing of equality of means. That's why we call it misnomer. That is, name is not reflecting, name is not reflecting what is the exact nature of the two. Okay, right? But Chital, since you have a statistical background, can you tell me why the word analysis of variance is being used for testing equality of means. Why ANOVA? Why this terminology ANOVA for testing of equality of means? Any one of you can try, give a try. Kuljit Kaur wants to talk. Let me give you permission, Kuljit. Yes, Kuljit, now you can talk.
So it is like testing the or checking the variability in means of different samples. That is why it is analysis of variance. Whether
Okay,
the means are whether there is a variation in the means of different sample and how significant it is.
but we don't testing for the difference in the means. We are we are not testing the variation of the means. We are testing the equality of means.
So it would be the contra side. When it does not come out to be equal, that means there are variations in means.
What is not equal?
When the means are not equal for different samples, it is
Uh-huh.
automatically implying that there is variation in different means.
Okay. What else? I think Santosh, you are talking about talking or Kuljit is talking. I don't know who is talking.
Sir, it's me, Santosh.
Kuljit, are you able to talk?
Sir, I just want to ask the same question.
Right.
I want the answer, sir.
Okay.
Thank you.
Friends, let's take 4 samples. Okay. So you have different observations in each sample, and you have the mean of each sample. Mean of 1, mean of 2, mean of 3, mean of 4. Okay. Suppose I say mean of it, first sample is 40. Then what does it mean? Some observation will be 39 here, some observation will be 40, some observation will be 38, some observations will be 45, 46, but overall the mean is 40. Okay. Now question is why we see variations within. Suppose this is my plant 1, this is my plant 2, 3 and 4. Why you find a difference in the variations, sorry, difference in the observations within a particular plant? Can any one of you think the reason why variations within a particular sample? Rajan, the approach to 40, that's good, but why there is a difference within the, why do we have a difference within the sample? If you ask me, I will say, I don't know. I don't know the reason why there is a difference. Why there is a difference within the plant 2, within the plant 3, within the plant 4? I don't know. That is something which is not explained. I cannot explain it because I don't have information much to explain it. And this kind of a variation is called variation within. Within variation is something that cannot be explained. This is unexplained. Okay. What about this? If there are differences in this means, can you explain why there are differences? Suppose the mean of the plant 3 is, say, 50, and the mean of the plant 4 is 30. I can say the differences in the motivation level of the people in these two plants is different because the plants are different. It is the plant that is causing the difference. So this kind of a difference is called variation among samples. So you will find that my total variation is being bifurcated into two parts, within and between the parts. Okay. Now I add one assumption to it, very strong assumption to it. I'm assuming that within variation, which you are observing, they are same. That's the assumption. All are having same within variation. So if within variation is same, then variation among the means should also be same. If I assume that plant-wise there is no difference, assumption is plants have no impact on the motivation level. If my null is true, that variation which I see within the sample, that should be reflected variation within the means. And that precisely analysis of variance does. Analysis of variance test equality of means by analyzing variances which are within the sample and which is across the sample or among the sample. Okay, so if I summarize my discussion, it will be something like this. You have the total variation of all the samples. The total variation can be bifurcated into two parts. Among the samples and within the sample. Among the sample 1, 2, 3, I can explain. I have a reason to explain that. I can explain it because the samples are different for different treatments. Samples are different for different identity. So I can explain that why there's a difference among the samples. But why there is a difference within the sample, I cannot explain. This is your unexplained part. Or you may call it error part. If my null hypothesis is true, means are equal, and so on. And this is true, and we make an assumption that variances are same across samples. Then variance among and variance within, that should also be equal. And we have a F statistics. That statistics gives me a test of equality of variance. So what exactly analysis of variance does? To check equality of means, it bifurcates the total variation into two parts, among and within, and then use F statistics to check whether these variations are same or not. If they are same, then the value of the F should be closer to 1. If it is closer to 1, that means there is no difference in the means. If it is very largely different from 1, then you have a reason to believe that means are different. That's precisely what is being done in analysis of variance. Okay, is that clear? If we assume that all samples are coming from the same population, or the treatment across has no effect, then the variation among means and the variation, the standard deviation across the groups will be due to only sampling error. That means we are dividing the total variation into two groups, variation within the group and variation among the group. So therefore, ANOVA tests equality of means among a number of groups via testing of equality of variations due to within the groups and among the groups. And accordingly, it defines the F statistics. When observations are subject to one experiment, we call it one factor or one-way analysis of variance. If you have two factors, you can have a two-way analysis of variance. Like suppose if I say that, anxiety is a function of age group and gender. Age group, I mean whether you are young, middle-aged, or old, like that. That means your anxiety is a function of two variables or two factors. If you analyzing this kind of a model, then you should use two-way analysis of variance. In this session, we will be talking about only one variable, one factor, and therefore our analysis will be one-way analysis of variance. Okay, ANOVA divide the total variation into two, among group variation and within group variation. Then we define null hypothesis, all are equal. Alternatively, at least two means are different. It assumes no difference between case sample behavior and their mean should be same. Alternatively, their mean should not be same. And we define F ratio, which is a ratio of two variances, variation between the groups or among the groups, divided by variation within the groups. Okay, so if my null is true, that means variation between the group and within the group should be same, and it should be approximately equal to 1. If it is larger than 1, that means between group is much having different as compared to within, and that is primarily because of the underlying factor which we are considering. Devinder Kumar is asking me, is it related to the concept of R square? Yes, it is related to the concept of R square. How it is related, that I'm not going to discuss here. Maybe it may be discussed in the regression session. But yes, there is a connection between these two. Okay. So let's note down the following points about ANOVA. It's a test of equality among means and not that of the variances. It has nothing to test about the variances of the sample. It says that at least two means are different out of k means from k samples. It assumes that variances of the population are equal. And it also assumes normality and scale level data. So these are the assumptions, and therefore analysis of variance is a parametric test. It's not a non-parametric test. Okay. So let's take this case. We have ANOVA table with us. We have a p-value which is 0.09, more than 5%. Null is not rejected, and therefore there is no difference in the motivation level of plant 1, 2, and 3. So we have variation between the groups and within the groups. Okay. Any question about it? Let's consider another example to get more clarity about analysis of variance. An experiment was conducted to understand recall mechanism among the people. How people recall their words which they have remembered. 50 people were selected and they were randomly assigned to 5 groups, 4 incidental learning groups, which are counting, rhyming, adjective, imaginary, and 1 intentional learning group. So 5 groups are being made. Each group was given a list of 27 words, and each one was asked to read them carefully 3 times and then give the responses. And we have collected responses, and this is the part of the data. This is not the complete data, but this is some part of the data which we have. Okay, now let's see. Priyank Kulshrestha is asking, if null is not rejected, then it means there is no variation. Priyank, please understand again. I'm repeating it again and again. Null is about means and not the variation. So if null is not rejected, that means all means are equal. They are not different. That's the meaning of rejecting null, not rejecting null hypothesis. Means are equal. Variation will exist, definitely will exist. Okay. I cannot say there is no variation. There is a variation, and but the means are equal. Yes. Priyank, let me take this example and I will explain everything with the help of this example. So we have taken different samples and we want to check whether the method of learning makes a difference or not. Okay. So what I'm saying is, if I took it as a causal module, so I am saying that is recall mechanism is a function of learning method. That is exactly we want to check. And we are discussing 5 methods of learning. If you say no impact of learning method, then all the methods should give you the same recall rate. That means mean recall rate of the 1 should be equal to that of the 2, should be equal to that of the 3, and so on. If they are not if they are different, then it means learning method has an impact on the recall. Yes, Shital, dependent variable should be normally distributed. That's the condition we have here. You're absolutely right. Yes, dependent variable should be normally distributed. So when I say it's normally distributed, I'm talking about dependent variable, which is measured on a scale level. Okay. So ANOVA is performed, and this is the basic statistics which you have. And this is the p-value. And now somebody was asking me earlier, what if the p-value is 0? In this example, p-value is 0, which is less than your level of significance, hence null is rejected. That means there is a difference in the way the people are learning and using that learning method in their recall mechanism. Okay, right. So we have the variation between the groups and within the groups. This is SS is sum of square of deviations from mean. So please understand that. SS represents sum of square of deviations from mean. So you take x minus x bar square and then summation of it. That's your SS. Yes, Abida, you're right. Null will be rejected in this case. Then for each one of it, we have degrees of freedom. And if we divide sum of square by the degrees of freedom, we get mean sum of square. Mean sum of square is nothing but variance. And F is variance between divided by variance within. And that's the p-value corresponding to it. Devinder Kumar, you are saying, can we say that variance within will never be equal to variance among? No. There may be some very rare cases, they might be equal, but I will never say that they will never be equal. Maybe equal, I don't know. But normally they are not equal. That you can say. But in rare cases, they may be equal. So I cannot generalize them. Okay, any question about this table? Otherwise, I will presume in our further discussion that you understand this table. Yes, Dr. Pawalkar, you can consider F greater than critical F, yes. But for that, you require the critical, you need the tables of F and the value of the F from the table. Degrees of freedom is how many groups are there? We have 5 groups. So 5 minus 1 is the degrees of freedom between the groups. Total observations are 50. So overall degrees of freedom is 49, and the difference is your 45. That's how we get it. F statistics gives me the ratio of variances between the groups and within the groups. F does not give the difference; it gives the ratio between the variance within the group and between the group. Shital, if you remember carefully, if this is the model I took, I said X should be categorical variable and Y should be scale level. So both need not be scale level. X should not be at a scale level. Uh, Santosh, I didn't say that F should always be equal to 1. For that, you have to look at the critical values of the F and then you take a decision. Suppose if you get a value of F point, it may not be significant, that you have to check. But closer to it, closer to 1, you have higher degrees of higher chances that you may reject it. Degrees of freedom means, Kapil, are you there? Anybody would like to explain what is Kuljit, can you try? Krishan Kumar, are you there? Okay, let me take an example. I say give me any 5 numbers. Any 5 numbers. You give me any 5 numbers. So what do you will do? Yes, Binu, you are right. How many values you can choose freely? Okay, Arun is giving me number 3, 6, 15, 86, 94. Okay, right. Now give me 5 numbers whose mean is 10. You know what does it mean? The moment you put a restriction, what will happen? You can take any number, 4 numbers freely. You're free to choose any 4 numbers. But the 5th one has to be selected in such a manner that the overall mean is 10. That means what's happening? In earlier cases, I was having full freedom to select all the 5. I put one restriction. I get freedom to select only 4. I put 2 restrictions whose standard deviation is equal to 5. Then you will find you can choose only 3 and with all freedom, but the 2 you cannot choose freely because you have a restriction on you. So degrees of freedom represents how many numbers in your sample you can select freely without, without violating the conditions which you are looking at. That's what is defined as degrees of freedom. Abida, a third degree of freedom is always n minus 1. No, it depends. More technically, if you ask me, n minus number of restrictions or conditions. That will give you the true degrees of freedom. Okay, n minus 1, when you presume that there is one condition, one restriction, but if you're having 3, 4, 5, 6 conditions, then so many degrees of freedom you are losing. Yes, Sheetal, you are right. N minus number of restrictions. Okay, great. Does the story end here? The answer is no. You have to check for homogeneity of variance. Okay, so in our example, it is coming to be 0.054 greater than 5%. Null is not rejected, then my variances are equal. So this assumption is true. Then we do what is called a post hoc analysis. The moment you say there is a difference, then question arises, where is the difference? Is the difference between mean 1 and mean 2? Or there is a difference between mean 1 and 3? There is a difference between mean 1 and 4? Where is that difference? ANOVA null hypothesis rejection says there is a difference, but where is that difference? If you really want to find out where is the difference, you have to go for pairwise comparison, and that is called post hoc analysis, multiple comparison. And you can see here, counting is different from imagery, counting is different from intentional. The star means significant. Rhyming is different from imagery and intentional. Adjective learning method is not different from other methods. Similarly, imagery is different from counting and rhyming. So now you can go deeper into it and find out if there is a difference, where is that particular difference? And to appreciate these differences, you can make a mean plot. And you can see they are saying this is very close to them, so it may not be different from here, but we see huge difference between these numbers and these numbers. Okay, Anu is asking, how do we interpret F? F is nothing but ratio of two variances. That's how we interpret F. F is a ratio of two variances between and within. Okay, so let's I hope you will start getting some Kuljit Kaur, I will come back to that comparison again, don't worry. And I hope we shall get some sense out of this too. Please note that when you are using ANOVA, you have to check for normality. And for normality, you can use KS test, which is called Kolmogorov-Simonov test. That's available in SPSS. You can also look for equality of the variances. You can do the post hoc analysis to have a pairwise comparison, and you can have a mean plot. These things you are supposed to do when you go for analysis of variance. Nirja, just wait. Neeraj, just wait. I'm going to answer this question. What post hoc analysis tool we have to use? Okay, recall the objective of the ANOVA, that's the causal research. Okay, so let's understand the output which we have. When you get the summary data before you You get an understanding that every sample is having 10 observations, that the sum, that their averages, that's their variations. And this is the F value, this is the P value, null is rejected. That's what you get overall picture about the data and about the problem which you are analyzing. KMO test AVIDA is used in factor analysis. That has nothing to do with ANOVA. Now, can we predict the recall rate? I ask you, what is the recall rate of the population? What your answer? If I ask you a question, what is the recall rate of the population? What your answer? Come out. So can we, just wait, I will explain to you. People are saying 10.606, some people are saying 10. Okay. If we have no information whatsoever, then my prediction about the recall rate will be 10.06, which is overall. Manjuri is saying we can, but not unique estimation. I don't know what you mean by that. Sheetal, no, we can predict recall rate by using ANOVA. Right. Now I give you a question. Recall rate, Sheetal. Now I'm going to talk about conditional thing. Given the fact that the method used is counting. Yes, Shampa Sarkar, uh, the best prediction for any population is its mean. So the average is taken to predict the overall rate. Yes, 7. Now, what is the advantage of it? The advantage of it is now I have additional information, and given that additional information, I can revise my prediction and avoid the errors in my prediction. Okay. Suppose if I ask you a question, what is the recall rate given the condition that it's a imagery system of learning? Definitely you will say it is 13.40. You know what is the relevance here? The relevance here is that if you have an additional information, then you can improve the quality of your prediction, and that will reduce the chances of errors. Pooja, again I say mean is better because of its good estimator qualities, unbiased, efficient, sufficient, and consistent. Okay. So it helps you in prediction. That's very, very important. Can you tell me how much variation of the total is explained? I don't know who was asking me what is the connection between R and F. Anyone of you? I don't know who was that person. Okay, forget. There was somebody who was asking me a question, what does it mean? Do we have a connection between F and R? I said, yes, we have a connection. And Devinder Kumar is asking what SS. In MS, SS is sum of square of deviations from mean, and you divide sum of square by degrees of freedom, you get mean sum of square, which is nothing but variance. Okay. Can any one of you tell me what is the total variation and how much is being explained by your learning method? Learning method is your factor. How much is being explained by the learning factor out of the total? 81%. I don't know. Deepa, how you got this 81%? Santosh? Arjun is saying 16.06. I don't know how they are getting. F is square. No. F is square is not that. My total variation is 786.82. That's my total variation. Out of this total variation, variation between the groups is explained variation, which is 35.1.52. So my ratio of explanation, the percentage of explanation is 351.52 over 786.82. That is nothing but your R square. That's how they are connected. Please understand that. Variation between the group is my explained. Within the group, I said earlier, I don't know why we have within the group variation. It is not explained. Okay. So you can easily calculate the variation explained by making use of the 31.52 divided by 786.82, that is 44.68. So out of the total variation, 44.68 variation is explained by the learning mechanism. Other factors might be age, other factors might be gender, other factors might be background, but one single factor learning mechanism is responsible for explaining 44.68%. Okay? So that's how we understand SS and MS. I think, Mr. Devinder, you got the answer to your question. How much variation is explained by each method? How do we get that? How much variation is explained by each that you can easily calculate by making use of it? Okay, so how do we get it? We get it 10.06 minus 7 square into 10. More of it, I will show you the calculations as we go further. You can not only find out the overall variation, you can also find out how much variation is explained by each group in the total. Tushti, R square is the acceptable. That depends upon your problem. That depends upon normally people say R square should be greater, but I tell you in finance, if my R square is coming to be 10%, I will be very happy with it. So if I believe that one factor can explain 10% out of thousands of variables, I'm very happy with it. So it depends upon the context and the problem with which you're working. Now, what are the policy implications? So if you have to suggest a method for learning, you will say imagery is one of the best method because this gives you the highest learning rate. And that will be the suggestion which you should give. So let's take another example, repeat the same process. What is the impact of different fertilizers on the production of wheat? So what we are saying, the fertilizer is a cause and wheat is the production of wheat is the effect. Okay, so let me go to spaces and I think I've shared a file with the name of fertilizer. Anova fertilizer, open it up. Okay, so let's see how do we do the analysis of variance in SPSS. So as usual, go to analyze. And friends, what we are doing, we are comparing means. So select compare means. And when you go for selecting compare means, you will come across with what is called one-way ANOVA. Click on it. What is your dependent variable? Production of the wheat is my dependent variable and fertilizer type is my factor. And I say, okay. What we get here, my p-value is 0.01, less than 5%. Null is rejected. Okay. Total variation is 514. That's how we get from here. And between group, that is explained, which is 254.40. Can any one of you tell me how much number is it? Do the quick calculation and tell me. This is, friends, nothing but your R square. Give me quick. Santosh Sabharwal is saying it's 49%. Okay. That means fertilizer is able to explain 49% variation in the production of wheat, and remaining 51% may be because of the other factors like quality of the soil, weather conditions, and timely giving water to the wheat crop. All those factors might be explaining the different 50% variation. Okay, right? Now, since you say null is rejected, now the question is, where is that difference? ANOVA in itself does not tell you that difference. You have to look for the difference and find out where is that difference. For that, you have to do, post hoc analysis. So go to one-way ANOVA. Variables I have already selected. Go to post hoc. And friends, normally I prefer to case B because it gives you also the grouping of the variables. That makes sense. Otherwise, you can make use of any one of them. They are equally well. Many people use Bonfrino, Scape, but I prefer to use the Tukey's post hoc model. Okay. If you want options, you can have mean plot. You can also test for homogeneity of variance. You can also get the descriptive. All these things are available under the options. I say continue, then I say okay. Uh, think let me Tuki gives you the pairwise comparison. Now you can compare it. Wherever you see the star, that is your point of you know difference. Here you have a difference. Here you have a difference. Yes. So fertilizer 1 is significantly different from 3. 1 is not different from 2. 1 is not different from 4. 2 is not different from 1, 3, 4. 3 is different from 1. That's how we get it. And we have the subsets, and you will find the 1, 2, and 4. They are of similar nature. You can have one, put them into one groups. 2, 4, 3, they are also similar in nature. But 1 and 3, they are basically huge difference between them. And that is also reflected in the mean plot graph. 1 and 3, they are significantly different. That's how you can understand this. Okay, anything else? I don't know, is the screen visible? 1 to 4 are similar because they are not significantly different. 1, 2, and 4, they are by and large in the same group. I repeat the post talk, so you go to analyze, compare means, one-way ANOVA, post talk, select two keys, and say continue. Okay, that's how we do it. Okay, Kuljit? Now you can see there are differences. 1, 2, 4, they look to be similar, but 3 is totally different from 1. That's the basic statistics which you can understand. Third is giving you the maximum output. Of course, it has more variation, but it also gives you the maximum output. Can we say that wheat production is impacted by fertilizer? The answer is yes, because it's 0. Null is rejected. That means fertilizer has an impact on production. Yogeshwari, I'm interpreting the results again. You can listen to it carefully. Manjuru is asking, ANOVA and design of experiments are related. The answer is yes, they are related. Then we see the difference here. This is different data, so you will find different methods, and you are. I'm using a different data set for this. The different groups you are getting. 1 and 2 combined, 2 and 4 are combined, and 3 is altogether different. Okay, just wait, Santosh. I will give you the answer for it. Can we predict wheat production given the information about fertilizer? The answer is yes. Wheat production given the information fertilizer 3 is used, that's so much. So fertilizer, wheat production given fertilizer 1 mean is 21. That's what you can predict. How much variation of the total is explained, that you can easily calculate. Friend, this data is different from what I have used. So you may get different values here. So, but 366.80 between is what is explained, and that's your total 490.800. This ratio will give me the variation which is being explained. And this is coming to be 74.735%. Okay. Then, how much variation is explained by each fertilizer? How do we calculate it? Mean of the first is 21 minus overall 26.60 raised to the power 2 into 5 observations. Okay, so that's the variance explained which we get, and that's the total, and you can find out the percentage. And you will find fertilizer 3 is having the maximum variation. And that's why I was saying it is having more impact. Its mean was also very high. Because of that, Santosh, I said fertilizer 3 is having more impact. Any sector, my screen is visible. It might be a problem at your end. What are the policy implications? The policy implication is that we should go for fertilizer 3 and try to get the maximum wheat output. So friends, when you do analysis of variance, not only the results are important, but their interpretation is also very important. And for that, you try to give the output as the percentage of the variation explained, the post hoc analysis results, the policy implications, all those things you have to discuss in your discussion about ANOVA. And testing of hypothesis, we can do testing of hypothesis by going for test of homogeneity of variance, and test of normality, we use what is called Kolmogorov-Smirnov test. And I show you how do we do it in SPSS. And let me do it again. Analyze one-way ANOVA. Options, homogeneity of variance test. Continue. Okay. This table is giving you homogeneity of variance test. Look at this value, 0.274. Null variances are same, not rejected, that means my that assumption of equality to the variance is satisfied. Uh, Dr. Sangeeta, if your error bar, I don't know what you mean by error bar, but if your variation explained is much higher, or the unexplained, the error explained, error term is not explained, that will be your, that means your results are not so good. I will not say valid, but I will say it's not good. Raghunath is asking me, yes, explained upon total gives me R square. Not R, but R square. Is that clear, Raghunath ji? Sangeeta, I think you got the answer to your question. This error term, or the mean error term, in itself, I cannot say good or bad. It has to be seen in the context in terms of the percentage explanatory power. Okay, for doing the normality test, Kolmogorov-Simonov test, it's a non-parametric test. We go to analyze non-parametric test, legacy dialog. Then you have one sample KS test, select that. Fertilizer production, normal test distribution, and then you say, okay. Look at this significant probability value, which is 8 point, sorry, 8.78. That means distribution is normal. Okay. Yes, Sheetal, test of homogeneity tests homogeneity the variance across a number of samples, more than two groups. Yes. And if there are violations of the assumptions, then you can make use of man-Whitney test. If it is two categories, then you can use man-Whitney test. If it is more than two categories, you can use Cruxel-Wallis test that you will study, discuss in the section on non-parametric test. Okay. This I can skip. Same thing, but you have to look at. So friends, how you feel about analysis of variance? Any question, any problem which you find in understanding it? Now let's see certain things which you have to connect. Is there any connection between ANOVA and t-test? Sheetal, tell me. Any connect between F and T? Any one of you tell me, is there a connection between F and T? ANOVA test for equality of means for multiple groups and uses F statistic, which is the ratio of two variances, while t-test is used testing for equality of the two groups. So if you have two groups and you apply F, ANOVA or t-test, the result will be the same, except t square is your F. So please remember, for two sample t-test, if you take a square of it, that will be exactly equal to f, which you get from ANOVA. Okay, so f is nothing but t squared for two groups problem. ANOVA can be used for testing equality of means, even two groups. Many people have an impression that ANOVA can be used only for groups more than two. That's not correct. Even for two groups, you can use it, and you can try yourself. Sheetal wants to get unmute. Let me check if I can unmute her. She
Sir, I have given her a permission. She can.
good. Another thing which we have to understand, you can see the significant value will be the same, but one is the square of the other one. Okay, so is y is a function of this, and you can make use of ANOVA provided assumptions are true. Okay, yes. Nilka, what I'm saying is, if you have two samples and you calculate f, you calculate 2t, then you will see t square is nothing but f. That what I was showing here, you can see here, that's t, that's f, and f is nothing but square of minus 2.642 square. And significant values are same. No difference. Are you able to hear me?
Yes, sir, your voice is absolutely fine.
Okay, so that's, friends, I want to discuss with you today. Any question, any doubt, if you have? Sheetal, you want to talk to me? You tell me what you want to say.
Sir, that is, you have asked me the question, that is, what is the relationship between T and F? So
Okay,
I want to answer. That's why I put that message.
okay, okay,
Okay.
great. Anybody else? No. So thank you very much. Thanks a lot. Enjoy. Have a nice time. All the best to all of you.
Thank you, sir. Thank you.
Thank
Thanks.
you so much, sir. Thank you
Thank
very
you.
much. We really had a great time, and the last 2 days of great learning and value addition.
Thank
Every
you.
time we listen to you, it's a great value addition for us, sir.
Thank you, Charu.
Thank you so much, sir.
Thank you, Charu.
Just a small announcement and a request to participants. The attendance is falling shortly. So please, you all are requested to be little considerate about this. Otherwise, the team might have to take strict actions. And tomorrow there is no session. Tomorrow there is a holiday. So enjoy and stay safe. Thank you.
एक्चुअली वो बंद करके आ रहा हूँ सिस्टम.
सर आप मीटिंग के होस्ट भी हैं, इफ यू कुड एंड द मीटिंग.
Okay, I do that.
जी सर.
है तो आपकी थोड़ी सी चीटिंग है वैसे। आपने पहले बोला था ट्यूसडे को खत्म, फिर आपने बोला ट्यूसडे को जम्बो.
Anjali ma'am, are you there? Purushottam sir. Yes, it is over for today, sir.